All right, last video. Woo! 28. Triangles LMN and OPQ are shown below. What additional information is sufficient to show that triangle LMN can be transformed and mapped onto triangle OPQ? So, important to keep in mind that the order of these letters is extremely important. If I'm saying LMN and then I'm saying OPQ, that means L corresponds to O, M corresponds to P, and N corresponds to Q. So just keep that in mind. Now, it gives you side LM is 12, LN is 10, OP is 8, PQ is 4. The angle M is 55, angle P is 55. Again, if they are truly similar, their angles are the same. Their sides are, sorry, let me focus that. Their angles are the same. Their sides can be ratio proportions. Okay, so this would mean that LM divided by OP is proportional to like LN divided by OQ, OQ, and that's proportional to MN divided by PQ, okay? So just so you remember what proportions mean. So A says OQ is 6, so it's saying this side is 6. Well, let's check that with this proportion. LM is 12, OP is 8, and that needs to equal 10 over 6. Okay, if I cross multiply, I would get 6 times 12 is 72, and 10 times 8 is 80. Well, no. Okay, 6 would not work as side OQ because the proportions are not equal, so it's not A. MN equals 9, so we can do the same thing. 12 over 8 is equal to, if I use 12 from the triangle, I got to use 9 first for MN. They're trying to say 9, so make sure that you're using the correct triangle sides. Over PQ they give us is 4. So again, cross multiply. 48 equals 72. No, it doesn't, so it's not B. All right, so let's look at our angles. Angle LMN, so go LMN, that's 55, is congruent equal to angle QOP. QOP. Well, to get the angle, you go in these 3-letter order, and it's always the middle letter. That's where the angle is. So QOP means they're talking about this top angle. So in the bigger triangle, I'm talking about the bottom left, and in the smaller triangle, I'm talking about the top angle, but those don't correspond. So it's not C. D, and angle NLM, NLM, so it's talking about the top angle now, is corresponding to QOP. QOP is also talking about the top angle. So yes, the answer here is D. Okay, that's the other piece of information to show that they can be transformed and mapped, that they are similar. All right, 29. The volume of a rectangular prism is represented with the expression x to the third minus 2x squared minus 20x minus 24. If the length is x minus 6 and the height and width are equal, what is the width of the prism? Okay, that means, remember what volume means, length times width times height for a rectangular prism. Okay, oops, sorry, volume is length times width times height. I'm given the length, and I know the height and width are equal. So let's divide this by our length. Okay, now you could do long division. I'm going to do synthetic division. Synthetic division says take the opposite of the factor, which is 6, a positive 6, and divide it into all of the coefficients. So 1 would be on x to the third, negative 2, negative 20, and negative 24. You bring down the first term. 6 times 1 is 6. Negative 2 plus 6 is 4. 4 times 6 is 24. Negative 20 plus 24 is 4. 6 times 4 is 24. That's my 0, which is good. Okay, translate this. So x squared plus 4x plus 4. So let's think about factoring this. X plus 2 times x plus 2. And since height and width are equal, one of these would be the height, one of these would be the width. So length, x minus 6, times height, x plus 2, times width, x plus 2, will get us this expression. So what's the width? A, x plus 2. It's one of the factors that we just got. Question 30. In a set of test scores that are normally distributed, a test score of 76 is 3 standard deviations below the mean. A score of 88 is 1 standard deviation above the mean. What is the mean of the data? All right, so let's draw a little bell curve. Okay, your mean always goes directly in the middle, so mean is represented with x with a line over top of it. 76 is 3 standard deviations below the mean, so we have 1, 2, 3 standard deviations below the mean, so this is where 76 is hanging out. 88 is 1 standard deviation above the mean. Okay, so we have kind of this range of 4 standard deviations between the 76 and the 88 that's happening. So how could we figure out the mean? Well, let's take the 88 minus 76 to get our difference of 12. Remember what I said, there's 4 standard deviations happening between the two of them. So I'm going to divide this by 4, which means I get 3. 3 is my standard deviation. That means each of these is jumping by 3. So to get from 88 down to the mean, I would take away 3 and get the mean as 85. You could also take the 76 and plus 3, plus 3, plus 3, and you should also hit 85. So your mean is 85. Draw a picture. Draw a picture, draw a picture, draw a picture to help you. Normal distribution is that bell-shaped curve, okay? Mean is always in the middle, and then we start breaking out to our standard deviations, with our standard deviations. Okay, this says short answer, but really it's just working out your work, showing your work. Okay. The function f is defined as f of x equals 6x to the fourth plus x to the third plus 4x squared plus x minus 2. If 1/2 and negative 2/3 are roots to f of x, then what are the other 2 remaining roots? If they are roots, that means if I take my function and divide it by the roots, I will get a 0 remainder, and then I can go through and figure out my other remaining roots. So I'm going to work with 1/2 first. Remember, you don't do the opposites here because they are telling us these are the roots. You only do the opposites when it's a factor. Okay, set up your coefficients, 6, 1, 4, 1, negative 2. Bring down 6 and divide. 6 times 1/2 is 3. 1 plus 3 is 4. 4 times 1/2 is 2. 4 plus 2 is 6. 6 times 1/2 is 3. 3 plus 1 is 4. 4 times 1/2 is 2. Negative 2 plus 2 is 0. So remember what I said, if it's a root, then it will end up in a 0. So we take our new coefficients, divide them by the second root, which is negative 2/3. Bring 6 down. 6 times negative 2/3 is negative 4. 4 plus negative 4 is 0. 0 times negative 2/3 is 0. Bring 6 down. 6 times negative 2/3 is negative 4. 4 plus negative 4 is 0. So I end up with a 0. Rewrite this so we can get our remaining roots. If this started with x to the fourth, my answer here would be x to the third. My answer here is x squared. So 6x squared, 0x plus 6 equals 0. Okay, there's no factoring or anything here. I'm just going to solve it for x. So minus 6, I get 6x squared equals negative 6. Divide by 6. X squared equals negative 1. Square root. We can't do a negative. Plus or minus, whenever we square root, we can't do the square root of a negative, but you guys learned about I. I is equal to square root of negative 1, so this would be plus or minus I. Just simply plus or minus I. Okay. 32. In the diagram, in the diagram of triangle OMP and triangle OQN, angle M is congruent to angle Q. So let's show that. Angle M is congruent to angle Q. And side MO is congruent to side QO. So M to O, this whole side, is congruent to QO. Based on the diagram, write a two-column proof showing that side MN is congruent to side QP. We didn't really get into two-column proofs. It was something that you've done in Math 2, and frankly, they shouldn't ask you to write a two-column proof, but they might have you do a drag and drop of the two-column proofs. or fill in the blank, or choose the correct answer. So we will go through right now how to do this. But again, we didn't hit on it because it was hit on in Math 2, and it's kind of just following the diagram and figuring out which sides, angles, etc. are congruent. So the first thing would be, well, you always have your statements and your reasons. Okay? Always first thing, write down what you have. They give us angle M is congruent to angle Q. Reason would be that it's given. Okay? Number 2, they tell us side MO is congruent to side QO, and your reason is just that it's given. Okay? Always write down whatever you have that is just given. All right. Next would be angle O, you could say, is congruent to what? Angle O. Angle O is congruent to angle O. It's working in both triangles, so you can make a note of that. And also, some of this can be written in different orders, so it can be written in different orders. And the reason here would be that it is just the same angle, right? It's itself. This is called the reflexive property, saying that a side is equal to itself, an angle is equal to itself. So the reason is that it's the same angle, but you'll probably see something like the reflexive property in your answer choices. Okay, so fourth statement would be we can start concluding that these bigger triangles are equal to each other because we have angle, side, angle equals angle, side, angle. So that's going to be my reasoning, is angle, side, angle. That was one of the triangle proofs that you should have learned in Math 2. So triangle, and you might label yours differently. I'm going to say OMP, but however you label yours, you need to label the other one in the same order. If I started with O, went down to M, then P, I need to go O, Q, N. So it's congruent to angle or triangle O, Q, N by angle, side, angle. Okay? Okay. If we have OMP is congruent to OQN, then we can also say that PO is congruent to NO. So PO is congruent to NO. Okay, and the reason is corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. If these triangles are congruent, we just concluded that, then their corresponding parts all also need to be congruent as well. Okay? All right, next reason would be that MN plus NO needs to equal MO, and QP plus PO equals QO. Okay? And the reasoning here is that we are adding, we know these two sides are equal, right? Because it was given to us. And we are adding, and since the smaller halves we just said are now equal, then the other corresponding parts also need to be equal. Okay? So this is just our addition postulate. So this is just our addition postulate. This is just addition. I'm just adding my parts of my side lanes. My side lanes were cut into parts, basically, and I'm adding them together. Again, I think you're going to have more of a drag and drop situation on your EOC or a fill in the blank. Not that you need to type out these reasons. I think it's going to be like a drag and drop sort of thing. Okay, so if that is true, then we can substitute our corresponding parts into our, we can set these equations equal, right? If MO equals QO, then we can set these equal to each other. So MN plus NO equals QP plus PO, and that is just substitution. Okay, I'm taking out the MOQO part, and I'm substituting the other side lengths in. If I subtract, or I should have, sorry, I'm changing PO to NO while I do this. I'm going to subtract NO from both sides, and I end up with MN equals QP, and that is what they wanted us to prove, that MN equals QP. So then side MN is congruent to side QP by definition of congruence. All right, so a lot of steps, a lot of statements, but remember your end goal. Always write out what's given to you. Remember your end goal and think about the different ways that you could get there. All right. Again, some of this could be moved around. You could have had a different 2-column proof, but this is one of the 2-column proofs that you could have had. Okay. 33. Given function g of x equals x plus 2 times 3x plus 2 divided by x plus 4 times x minus 2 times x minus 6. What are the equations of the asymptotes of the function? What are the intercepts of the function? Determine if the function has a whole. If so, what is it? What is the end behavior of the function? Guess what? Plug this into Desmos. Some of this you need to figure out without plugging into Desmos, but plug into Desmos so that you can see the picture. Now, first thing is if we cancel anything out, and you can cancel the same things that are top and bottom, remember that they make a whole. So I can cross out x minus 2, x minus 2. That would mean that I have a whole. Okay? Just keep that in mind. So bring this down, it equals 3x plus 2 over x plus 4 times x minus 6. Okay? And so the bottom can never equal 0. That means those are my asymptotes. So for part A, my asymptotes are at x plus 4 equals 0, which means x equals negative 4. That's the equation. And x minus 6 equals 0, x equals 6. That is the equation. So you have vertical asymptotes at x equals negative 4 and 6. And you look at our degrees in order to get our horizontal asymptotes. This also becomes 3x plus 2 over x squared minus 2x minus 24. So our degrees above, our degree of the numerator is 1. Our degree of the denominator is 2. So our horizontal asymptote is y equals 0. But again, a lot of this you can get from looking and interpreting it from the graph on Desmos. Okay? All right, so B is for a whole, and remember what I said, you get a whole if things cancel out. So for B, our whole was at the x minus 2. That means x equals 2, and we need to plug 2 in to get the y. So x minus 2 is our whole. That means x equals 2. Plug 2 back into the equation here to get your y. 3 times 2 plus 2 over 2 plus 4 is 6. 2 minus 6 is negative 4. So I get on top 8 divided by negative 24, which means I'm at negative 1/3. So my whole is at 2 comma negative 1/3. And you should see that on Desmos as a little hole. Remember, it doesn't show up right away, but if you drag your mouse over to 2, you will see a hole there. All right, C, what are the intercepts of the function? To get the x-intercept, we set the top of the equation equal to 0 and solve. I'm going to come up here. So you take the top part of the equation, 3x plus 2 equals 0. Solve. X equals negative 2/3. I'm not going to go through the steps because, again, you can see it on Desmos. The y-intercept, again, you can see it on Desmos. The y-intercept just goes from the parts without x on them, so it is negative 2 over 24, which just comes down to negative 1/12. So there's a y-intercept at 0, comma, negative 1/12, and an x-intercept at negative 2/3, comma, 0. Again, see it through Desmos. And then D for the end behavior. I'm going to show D down here. Kind of all over the place, sorry. As x approaches negative infinity, what's happening to y? Again, looking at Desmos, y goes to 0. As x goes to infinity, what's happening to y? Y goes to 0. Because the horizontal asymptote is 0. So y is going to be approaching 0 on both parts. Okay. Getting there, guys. 34, the value of an account that is being compounded continuously. That means we're going to use our E equation. Is given by the formula, and they give you the formula, which is so nice. A equals P times E raised to the RT. What is the interest rate as a percent to the nearest 10th place of an account in which its amount is doubled and compounded for 16 years? So P, A, R, T. What does everything equal? P is 1, A is 2, since I want to double P, okay? Because I'm looking for a year, right? The interest amount in a year. And T, they give us a 16 years, and R is what we're trying to figure out and solve. So I'm going to use my paper here. You guys should be doing this on probably separate sheets of paper because there's just not enough room as well. So let us plug everything in. We get 2 equals 1 e to the r times 16. And we can divide by 1, right? But that really just goes away. So we get 2 equals e to the 16r. So remember, if you don't know something in the exponent, you're going to do a log. However, when it's e, you're going to do the natural log. You're going to do the ln button. So ln of 2 equals ln of e, and your exponent will go in the front, 16r. Divide by ln of e, divide by ln of e. If you do that in the calculator, well, the ln of e really just becomes a 1. So you're still stuck with ln of 2 equals 16r, divide by 16, divide by 16. So you're doing ln of 2 divided by 16 in the calculator. R equals 0.0433, etc. Move your decimal. 4.3% is your rate. All right, last one. What is the solution to the equation? 3 divided by x plus 2 divided by x divided by 5 plus 1 equals 15x. Whew, a lot going on here. All right, so since this is a proportion technically, we could cross multiply. So trying to see if we can simplify this a little better. You can probably hear my cat meowing. Let me pause really quick. Okay, so first thing I would do is get my LCD of the top and the bottom fractions on the left side. My LCD would be 5x because I have a 5 on the bottom and an x on the bottom. I'm going to multiply both of these by that 5x. When I multiply 5x to the 3 divided by x, I end up with 3 times 5, which gives me 15. The x's go away. 2 times 5x is 10x. Over 5x times x divided by 5. The 5's would go away, the x would times x, and you would get x squared, plus 1 times 5 is 5x, equals 15 over x. Now I can cross multiply since I have a proportion. So x is going to multiply to the 15 plus 10x, and I'm going to get 15x plus 10x squared equals 15 is going to multiply to the other side, 15x squared plus 5x. Okay. So I'm going to take away the 15x and the 10x squared, minus 10x squared minus 15x. I get 0 equals 5x squared minus 10x. Let's take out a GCF. Sorry, I just correspond to my answer key to make sure I'm on the same track. What did I mess up? Oh, 15 times 5, guys. 15 times 5 should have been 75. So it should have been 75x. 75x minus 15x is 60x. I'm going to take a GCF out, which is 5x. I end up with an x minus 12 plus 12. What is wrong with me? And set both of these equal to 0. Divide by 5. So x equals 0 minus 12. X equals negative 12. So your answers are x equals 0, x equals negative 12. Let's check back into here. Well, we can't have x being a 0 because we would end up with a 0 under my denominator and a 0 under my denominator, and I can't do that. So this is extraneous. So my answer only is x equals negative 12. Remember about your extraneous solutions, you can't have the denominator ever equal 0. If it happens, it's not a part of your solution. So that is the end of the first EOC review that you should be watching and completing while I am not at school on Friday, and continue into Monday if you don't get it done. Okay? Make sure to highlight any questions that you thought were really confusing that you want me to go over on Tuesday when I come back to school, and I will be happy to do that.